I was working a job once where we were doing some onboarding training for the controls team, and fortunately I was actually taking it with an old colleague of mine. That this was like our second or third company together, and we were excited to be doing something together again. And the instructor got to a portion over hexadecimal and kind of sighed and said, guys, I'll be honest, I have no idea how hexadecimal works or why we would use it, but, I've made it this far in my career, and I've never needed it, so it's fine. We're just going to move on. And my colleague and I were in the same room, kind of looked over at each other, and simultaneously realized together, like, what kind of company doesn't think the controls team needs to know hexadecimal? Hello, welcome to Chaos and Controls, a show where we talk about modern devices, technology, and techniques for automating your home, business, or life. I'm your host, the Automation Doctor. Today, I thought we could talk about hexadecimal, where you might use it, why it's useful, and why it's really not nearly as difficult as that instructor might think it was. Let's start with the basics. For instance, why would you even want to use hexadecimal? And if you recall from the binary video, computers, generally speaking, like to have things on or off. They're digital creatures. And in binary, that's a very convenient place to start, because everything is a 0 or a 1. It is on or off. Hexadecimal, subsequently, is a extension of binary, you can think of it, because 2 times 2 times 2 times 2 is 16. Hexadecimal is base 16. And so a hexadecimal value really is a 4-bit number in disguise. And in binary, I would say that I can count from 0000 to 1111. In decimal, I would say that I can count from 0 to 15. And in hexadecimal, we would say that I can count from 0 to F. As a matter of fact, let's go ahead and do that. We'll count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. You'll notice that I've got 16 characters that represent the values 0 to 15. You'll also recall that I just said that you can use hexadecimal to represent 4 bits. In something like an IP address, we typically have a byte of data, or 8 bits. So I can represent 8 bits of data with 2 hexadecimal characters, which is why we might want to do that. And you'll notice things like MAC addresses or IP addresses, typically when we're using like IPv6, all use hexadecimal nomenclature. So an easy one to recall is 255. In binary, that would be 8 ones, or 111, 11111. In hexadecimal, that would simply be FF. You'll notice, rather conveniently, that 2 digits now always represents 8 bits, which is a much more condensed version. And even compared to decimal, where we are using 3 digits, we're now saving a space, and we don't have any of these weird round-offs where we get to 255 and now we have to discard the rest of the decimal system because we're trying to use a numbering system convenient for the computer, not the human. So let's take an example from a previous video. You'll recall that in the IP addresses video we talked about the loopback being at 127 dot something. If I wanted to represent 127 in decimal, it's just 127. If I wanted to represent it in binary, it would be a single 0 followed by 7 ones. If I wanted to represent it in hexadecimal, it would be 7F. And I can show you on the screen right here. This is breaking apart why that is. You'll notice that in the first 4, we have a 0, 1, 1, 1, which is 7, followed by an additional 4 ones, which is 15, or F. Another example I can go ahead and throw up on the screen here is 192, which you may recognize as what your home network is probably on, a 192 dot something network. Usually 192.168.0. Insert IP address here. But in any case, if I wanted to convert 192 to hexadecimal, it is C0, and I can break that apart right here. And there you have it. That's really all there is to hexadecimal. At the end of the day, it's just a convenient method for expressing binary values. Now, we use it in all sorts of things. It can be convenient for reporting things on data sheets or in other bitwise operations. It crops up anywhere that we use binary, and that's pretty much everywhere that we use computers. And as long as we continue to have 8 bits to a byte, I foresee that it'll probably have a place anywhere that we use computers. The last thing that's probably worth talking while I've got you here is the way that we denote what kind of a number something is. And there's a couple different ways, and for whatever reason it seems to throw people off. But you'll see a little 0x in front of a number oftentimes, and that is simply there to indicate that it is a hexadecimal number. You can also do a 0b to represent a binary. Subsequently, I can also have a subscript at the end with the base that I'm in. If it's base 10, subscript 10. If it's a binary number, subscript 2. Hexadecimal, subscript 16. Nothing particularly nefarious about it, just know that a lot of times, one way or the other, when you're dealing with anything in a computer and it's a number of some sort, they are going to show you some denotation somewhere to indicate what kind of a number it is you're looking at. In any case, that's all I've got for you today. You all have a good one. I'll catch you next time.